Hypotheses are not something you add because a template includes them, and they are not a place to restate your personal hopes for the study. Hypotheses come at a very specific point in the logic you have been building. You only write hypotheses after the phenomenon is clear, the tension has been named, the consequence has been established, and the literature gap has revealed what is missing. You have already selected your methodology, chosen your quantitative design, written your purpose statement, and written your quantitative research questions using the correct alignment verb. Hypotheses come next because they translate those quantitative research questions into statements that can be tested statistically. A hypothesis is a testable statistical claim stated in measurable terms. It is not a research question, not a topic sentence, not a goal, and not a solution statement. A hypothesis must use the same variables already named in your purpose and research questions, and it must be written so that a specific statistical analysis can test it. If the variables are unclear, if they are not measurable, or if the statement cannot be evaluated by a test, then it is not a hypothesis yet. This is why hypotheses only belong in quantitative work. Qualitative studies do not use hypotheses because qualitative questions seek meaning, experience, and interpretation, not statistical testing. In mixed method studies, hypotheses can exist, but only in the quantitative strand. You also need to be clear about when hypotheses are required and when they are not. Hypotheses are typically written for inferential quantitative studies because inferential tests are designed to evaluate relationships, predictions, differences, and associations. Purely descriptive studies typically do not use hypotheses because descriptive work does not test anything. It summarizes what is present through counts, averages, and distributions. It is also important to be honest about the level of rigor expected in dissertation research. Descriptive-only designs are rarely appropriate as a standalone dissertation because they usually do not produce the depth of inference expected at the dissertation level. Descriptive statistics can be part of a dissertation, but a descriptive-only dissertation is uncommon because it rarely answers the deeper, so what, implied by doctoral work. To write hypotheses correctly, you have to understand two forms: the null hypothesis and the alternative hypothesis. The null hypothesis states that there is no relationship, no difference, or no association. The alternative hypothesis states that a relationship, difference, or association exists. The statistical analysis is designed to test whether you can reject the null hypothesis. It does not prove the alternative in a final or absolute sense. It evaluates evidence. If the evidence is strong enough, the null is rejected. If it is not strong enough, the null is not rejected. That is why hypotheses are written in careful, testable language rather than in certainty language. You also need to understand the difference between directional and non-directional alternative hypotheses. A non-directional alternative hypothesis states that a relationship, difference, or association exists, but does not predict the direction. A directional alternative hypothesis states the direction that you expect, such as one group scoring higher than another or one variable increasing as another increases. In dissertation work, non-directional hypotheses are often the default unless prior research clearly justifies a directional prediction. Direction comes from defensible evidence in the literature, not from preference. If you do not have strong prior evidence to support a directional claim, you write the alternative hypothesis in a non-directional form. From here, everything becomes alignment. The verb in your quantitative research question tells you what the analysis must be, and the analysis tells you how the hypotheses must be written. If the verb in the question is relationship, the analysis will be correlation, and your hypotheses must be stated in terms of a relationship between two variables. If the verb in the question is predict, the analysis will be regression, and your hypotheses must be stated in terms of prediction, with a predictor and an outcome. If the verb in the question is association, the analysis will be chi-square, and your hypotheses must be stated in terms of association between two categorical variables. If the verb in the question is statistically significant difference, the analysis will be a group comparison test, such as an independent samples t-test, paired samples t-test, ANOVA, ANCOVA, or MANCOVA, depending on the number of groups, whether the scores are paired, and whether you are controlling for covariates. Hypotheses do not come first. They come from the question you already wrote. To write a hypothesis, you must also understand the role of variables, because each type of analysis requires a particular variable logic. For a relationship question tested with correlation, both variables are measured and typically continuous. For a predict question tested with regression, you have a predictor variable and an outcome variable, and you are estimating the extent to which the predictor explains variation in the outcome. For an association question tested with chi-square, both variables are categorical, and you are assessing whether category memberships are related. For a statistically significant difference question tested with a t-test or ANOVA family analysis, one variable defines groups and the other is a measured outcome, often continuous. If your variables do not match the analysis, the hypothesis cannot be tested. That is why hypotheses must always be written with measurement in mind. Now you can see how each hypothesis form pairs tightly with an analysis. Correlation tests whether there is a relationship between two measured variables, and it does not claim cause. Regression tests whether one or more predictors predict an outcome, and estimates how much variance is explained, but prediction is still not automatic causation unless the design supports causal inference. Chi-square tests whether there is an association between categorical variables. Independent samples t-tests compare the means of two independent groups. Paired samples t-tests compare two related measurements from the same participants or matched pairs. ANOVA compares means across three or more groups. ANCOVA compares means while controlling for one or more covariates. MANCOVA does the same while analyzing multiple outcome variables together. The reason this matters in a hypotheses video is simple. The analysis is not chosen after the hypothesis is written. The hypothesis is written so that the analysis you already know you must use can test it. Here is what alignment looks like when it becomes writing. Imagine a correlational study where the research question is, what is the relationship between teacher self-efficacy and student engagement in high school classrooms? The null hypothesis is that there is no statistically significant relationship between teacher self-efficacy and student engagement. The alternative hypothesis is that there is a statistically significant relationship between teacher self-efficacy and student engagement. Because the verb is relationship, the analysis is correlation, and the hypotheses must be stated in relationship terms rather than prediction or difference. Now imagine a regression example where the research question is, to what extent does student attendance predict academic performance in 9th grade students? The null hypothesis is that student attendance does not significantly predict academic performance in 9th grade students. The alternative hypothesis is that student attendance significantly predicts academic performance in 9th grade students. Here the verb predict is inside the question, which is what forces the regression logic and the prediction language in the hypothesis. Now imagine a chi-square example where the research question is there an association between instructional modality and course completion status in high school students? The null hypothesis is that there is not a statistically significant association between instructional modality and course completion status. The alternative hypothesis is that there is a statistically significant association between instructional modality and course completion status. Because both variables are categorical and the verb is association, the analysis aligns with chi-square and the hypotheses must be written in association terms. Now imagine a group difference example where the research question is there a statistically significant difference in reading achievement between students who participate in a tutoring program and students who do not participate? The null hypothesis is that there is no statistically significant difference in reading achievement between students who participate and students who do not participate. The alternative hypothesis is that there is a statistically significant difference in reading achievement between students who participate and students who do not participate. Because the verb is statistically significant difference, the analysis aligns with a group comparison test. If there are only two independent groups, the test would align with an independent samples t-test. If there were three or more groups, the test would align with ANOVA. If you were controlling for a covariate such as baseline reading score, the test would align with ANCOVA. If you had multiple outcomes such as reading achievement and writing achievement, the test could align with MANCOVA. The hypotheses stay aligned to the research question form while the specific test is chosen based on the structure of the data. Most hypothesis problems come from misalignment. One common error is inserting causal language into a correlational hypothesis, such as writing that one variable causes changes in another when the design does not permit causal claims. Another common error is writing hypotheses for descriptive studies, which are not testing anything. Another is failing to define variables clearly, leading to hypotheses that cannot be measured. Another is mixing multiple tests into one hypothesis, which makes it unclear what will actually be tested. Another is writing directional hypotheses without evidence strong enough to justify direction. The fix is always to return to the alignment chain. The design determines the research question verb, the verb determines the analysis, and the analysis determines the hypothesis form. Hypotheses exist to make your quantitative strand cohesive and defensible. They are the statistical version of your research question, written so a specific analysis can evaluate exactly what you claimed. When your hypotheses match your design, variables, and analysis, the study reads as aligned from beginning to end, and the transition into instruments, sampling, and data analysis becomes far clearer, because the logic of what you are testing has already been written precisely.